All right, welcome back to our unit on chemical reactions. Today's topic is classifying chemical reactions. Lesson 2 of 3, your objectives are as follows. To learn how to recognize and distinguish between 6 reactions and their general formulas. To learn how to write and complete chemical equations. For your quick write. In the general reaction below, which letter or letters best represent a compound between two elements? Which letter or letters represent a pure element? In the same reaction below, describe which letter E is replacing after the reaction. What comes to mind when you think of the term combustion? What comes to mind when you think of the term replacement? Okay, go ahead and pause this while you do. Quick write. I'm going to move on. Okay, so classifying reactions. Many different types of reactions take place. Most reactions can be classified into 6 general types: combustion reactions, decomposition reactions, combination or synthesis reactions, and single replacement reactions, and double replacement reactions. And then finally, acid-base reactions. Okay, so combustion reactions. Many chemical reactions that involve oxygen produce energy or heat so rapidly that a flame results. Such reactions are called combustion reactions and are highly exothermic, which means they release heat. For example, consider the reaction that occurs between methane, natural gas, and oxygen in your Bunsen burners. Okay, so methane comes out, reacts with oxygen in the air to produce CO2 as a gas and water vapor as a gas. This reaction creates the flame for your laboratory Bunsen burners. There are many other combustion reactions. Consider the reaction between propane gas and oxygen that occurs in many outdoor barbecue grilling stoves. Down here is your propane tank. Well, propane plus oxygen makes CO2 and H2O. Or the reaction that occurs in your car engines where octane combusts with oxygen, where octane here in your car reacts with oxygen to produce CO2 and once again water vapor. Hopefully you're noticing a trend here in what's produced. So combustion reactions have the general formula: a hydrocarbon, C subscript X, H subscript X plus oxygen creates CO2 and water. So on the reactant side, like I said, C subscript X and H subscript X represents a hydrocarbon, methane, propane, octane, and so forth. And oxygen gas, O2, and the products that form are carbon dioxide and water, H2O. So for your notes, what is a combustion reaction? Question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you write, and I'm going to move on. Okay, so decomposition reactions. In many cases, a compound can be broken down into simpler compounds or all the way to the component elements. A decomposition reaction occurs when one large reactant breaks down into 2 or more smaller reactants or products. The word decompose means to break down or break apart. So decomposition reactions are the opposite of combination reactions. They have the general formula, XY breaks down into X plus Y. So notice, a larger chemical breaks down into simpler substances, So if an electric current is passed through water, H2O, it will break down into H2 and oxygen gas, So if we add electricity here to water, notice these bubbles form. Well, what's those bubbles? So the reaction, H2O, produces hydrogen gas and oxygen gas, is a decomposition reaction because water is breaking down or decomposing into simpler molecules here, H2 and O2. So water is in here with an electrical current, it'll break down into 2 simpler substances, H2 and O2. We call this reaction hydrolysis. It's also how we make rocket fuel for the space shuttle. So for your notes, what is a decomposition reaction? Question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you write. I'm going to move on. All right, so synthesis or combination reactions. Synthesis or combination reactions occur when two or more small reactants form one larger product. Think of it as the opposite as a decomposition reaction. Okay? Combination reactions have the general formula X plus Y makes XY, a larger compound here. So notice the small reactants, okay, combine to make one larger compound as a product. For example, when iron reacts with oxygen, it produces rust, Fe2O3. So here we have iron. So here's iron and here's oxygen. Okay. Well, notice the oxygen is going to bond with the iron to make rust, Fe2O3. So this reaction is a combination or synthesis reaction because a larger product, okay, iron oxide here, forms from two simpler reactants, iron and oxygen. Okay, so it is a combination or synthesis reaction. So for your notes, what is a combination or synthesis reaction? Question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you write. I'm going to move on here. Okay, so single replacement reactions. In a single replacement reaction, an element reacts with a compound to form a different element in a different compound. The key to identifying these reactions is to notice which element is being replaced or substituted for one another. The reactant compound is usually an ionic compound. The general equation for a single replacement reaction is E plus XY produces EY plus X. So one way to extract silver is from the single replacement reaction below. Okay, copper plus silver nitrate will produce copper nitrate in pure silver. Okay, so here we have copper wire. Okay, and over here we have, okay, our silver nitrate atoms. So notice, okay, the silver is replacing the copper. Okay, so this is actually silver here forming on the outside of copper wire. Okay, in other words, okay, the silver here is replacing the copper. Okay, and we get pure silver on the outside of copper here. So notice the starting element copper, like I said, has been replaced by silver. It is a single replacement reaction. So for your notes, what is a single replacement reaction? Okay, question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you write. I'm going to move on here. Okay, so double replacement reactions. In a double replacement reaction, the ions in two compounds trade or switch places, forming two new compounds. The general equation for a double replacement reaction is AB plus XY creates AY plus XB. Notice the elements or ions A, okay, and X have switched or traded places with Y and B. Okay, so A here and X, all right, X is now with B. Okay, and A is no longer with B here, and it is with Y. So they've switched places, forming two new compounds. Many double replacement reactions take place in water. They are aqueous and form solids or precipitates. So here you can see a double replacement reaction where a white solid or precipitate forms. Okay, so for example, consider the double replacement reaction below when salt, good old table salt, sodium chloride is mixed with silver nitrate and water, and a white milky solid forms. Okay, so here we have two solutions. We have sodium chloride ions floating around in water. Okay, we have silver nitrate ions in here floating around in water. Okay, we're going to mix these two, sodium chloride plus silver nitrate here. So, like I said, we have two solutions, a solution of sodium chloride and a solution of silver nitrate here. Okay? But what happens when these two solutions are mixed? Well, let's find out. Let's take some of our sodium chloride solution, okay, and mix it with our silver nitrate solution. So notice here, we have sodium and chlorine ions floating around with silver and nitrate ions. Notice the silver and the chlorine ions bond to make a white solid or chemical, to make silver chloride. We call this a precipitate. So when mixed together, silver cations bond with chloride anions, forming a white solid or precipitate. Okay? After the white solid forms and sinks to the bottom, the sodium and nitrate ions are still left dissolved in water. Okay, they are what we say aqueous. So notice, this double replacement reaction, the ions have swapped positions. Here we have sodium and chlorine ions in solution or water, and silver and nitrate, and after the reaction, they have swapped positions. Okay? And that white solid is silver chloride. Okay, down here at the bottom. So, for your notes, what are double replacement reactions? Okay, question on the left-hand side. As always, answer goes on the right-hand side. Go ahead and pause this while you write. I'm going to move on. Okay, so the last reaction type is acid-base reactions. When an acid such as hydrochloric acid reacts with a base such as sodium hydroxide, it is possible to predict what forms. Consider the reaction below, where hydrochloric acid reacts with sodium hydroxide to make sodium chloride, a salt, and water here. Whenever an acid and a base react, an acid donates a hydrogen atom to a base producing salt, okay, and water as a product. Okay, a salt is basically an ionic compound. So, for your notes, what are acid-base reactions? Okay, question on the left-hand side, answer goes on the right-hand side. Go ahead and pause this while you write. Okay, I'm going to move on here. Okay, so writing and completing chemical reactions. One thing chemists do on a regular basis is to write chemical reactions. Throughout the rest of the year, many labs will require you to write chemical reactions and predict the products that form. So, practice, okay? Complete the chemical reaction below. So, read this, okay, and follow the directions here. When you're ready to check your work, okay, go ahead and hit play to see how you did. So go ahead and pause this while you work on this and hit play when you're ready to check your work. All right, let's see how you did. So when heated to high enough temperature, solid potassium chloride will produce solid potassium metal and chlorine gas. So what's going in these question marks, basically? So write the chemical reaction and basically balance it. And then classify it here. What kind of reaction is it? So solid potassium chloride will produce, chlorine gas, which is a diatomic molecule, and solid potassium. Balanced, we have to put a 2 there. So I would say it's a larger one breaking down into 2 simpler ones, so we call this a decomposition reaction. Okay? Hopefully you got that right. Okay, so once again, practice. Go ahead and pause this. Try this on your own. Let's see how you did. Okay, so hit play when you're ready to check your work. All right, let's see how you did. So calcium metal plus hydrochloric acid, HCl, produces aqueous calcium chloride and hydrogen gas. All right, so calcium metal, okay, it's a single element, okay, will produce hydrogen gas, H2, so it's a diatomic molecule, okay, and make sure it's balanced here. We have 1 calcium, 2 hydrogen, 1 chlorine, or 2 chlorine and 2 chlorine. So we're good. Now determine what kind of reaction it is. Well, it looks like calcium here, okay, is kicking out hydrogen and replacing it to make calcium chloride. So I would call it a single replacement. Okay, so once again, go ahead and practice this. You'll get the hang of this here after more and more practice, okay, the better you'll become. All right, so go ahead and pause this when you're ready to check your work, hit play. All right, let's see how you did here. So solid magnesium metal is burned in the presence of oxygen gas. It produces solid magnesium oxide. Okay, so O2, oxygen gas, is a diatomic molecule. Okay, so magnesium plus oxygen will make magnesium oxide. Okay, MgO. Make sure it's balanced. 2 Mg, 2 Mg, 2 oxygen, and 2 oxygen. Good. Well, it looks like two simpler elements or compounds are combining to make one larger compound. So I would call this a combination reaction. Okay, or synthesis. All right, hopefully you got that right. Okay, last one. Ethylene gas reacts with oxygen gas in the air to produce carbon dioxide and water. Go ahead and pause this while you do this. Okay, when you're ready to check your work, hit play. All right, let's see how you did. So ethylene gas, here is a hydrocarbon, reacts with oxygen to produce carbon dioxide and water. Okay, so let's throw down our oxygen, okay, and our carbon dioxide, CO2, balanced. We have 3 oxygen, okay, 6 oxygen here. We have 4 oxygen and 6 oxygen total on this side. So it looks like we're good. 2 carbon and 2 carbon. Well, based on the fact that it's a hydrocarbon with oxygen to make CO2 and water, I would call this a combustion reaction. Okay? Hopefully you got that right. Okay, so go ahead and summarize. Remember, you can always write your own. Okay? So go ahead and pause this while you work on your summary, and we'll see you next time.